Hi, my name is Scott Wadden, DSRW on GitHub. I work for Shopify and I've been programming in Nim for 6 years. Emu is a multiplayer 3D live programming environment, kind of like Minecraft meets Logo with a weird state machine DSL bolted on top. Inu is MIT licensed, written in Nim, and the in-game scripts are written in Nim as well. It's based on Godot 3, but there's a working Godot 4 port that will be part of a release later this year. Inu is for teaching coding, experimenting, making games, and just having fun. Someday there'll be a way to share and discover games or even make standalone games, but that's a ways off yet. I've taught Inu in schools, and there are a few folks using it online, but right now Inu is mostly used by me and my family. Most Inu programs run in the Nim VM, but it's possible to write out-of-process native programs that interact with Inu as well. Inu's data is stored in ed objects, reactive containers that sync across threads in the network. In most cases, adding to Inu's world means initializing the right object and adding it to the right container. Let's write a program that connects to Inu, instances a bot, and then adds it to the root units collection, so we'll see it in the world. First, we'll import the Inu client and the bot model. Now we'll connect, and we'll add a new bot. Now we'll build and run our program with the nimr command. There's our bot. Our program immediately exited after adding it, so they're not long for this world. The disconnected bot should be cleaned up automatically in 10 seconds. So long. By default, units are ephemeral, so if we want to keep it around, we need to keep the context alive. The bot will stay on the world until our program exits or we get disconnected. I just hit Command C, and the bot is gone. Let's make the next one move. We'll grab a reference to our bot instead of adding it directly to the collection. Next, we'll capture our starting position and we'll code our bot to move 16 meters along the z-axis over 3 seconds. If you ever wanted to move a robot backwards across a purple floor in a straight line, well, now you can. Let's try a build instead of a bot. By default, a build is just a single block, so that's all you get for now. Let's add a few more voxels. We'll have to import the colors module so we can set different block colors. Now we'll add voxels in a for loop. Draw takes the position, a voxel type, and a color. There are computed voxels and manual voxels. Computed voxels get cleaned up automatically each time a script runs. There's our build. Let's try something bigger. Here's a program to generate a nautilus shape. It will be black with multicolor lines spiraled throughout. I'm not really a math guy, so Claude helped me with this, but it uses trigonometry to create a large twisting tube that expands outward logarithmically. And there it is. A little slow, but we'll do something about that in a minute. Neat. Let's try a bigger one. Looking good, but really slow. Let's turn on buffering so we don't have to rebuild the geometry every time we add a block. Our program exits after building the Nautilus, so it's getting cleaned up after 10 seconds. Let's wrap everything in a buffer block. That's a lot better. Let's make it even bigger. And it's gone again. I'm happy with our Nautilus. Let's have it persist in the world after the program shuts down. We'll switch our computed blocks to manual, then we'll add save equals true to the build initializer. This is a fairly straightforward way to build in regular nim code and then have it saved in the world. Sometime soon I plan to add a Magivoxel importer using this technique. I'd like a way to make Inu levels with agents. Let's make an Inu MCP server that an agent can connect to inspect the Inu world. I could build this into Inu itself, but instead I'll make it an external program that connects with an Inu client. We'll start by importing NimCP, a nice framework for building MCP servers easily. Then we'll import the bots and the color modules. Next we connect, initialize our bot, create a custom color, assign it to our bot, add it to the units collection. In the last demo, this was called root units, but I renamed it. Create an MCP server and give it a name and a version. Add an eval tool that takes a string and evaluates the code in the bot's context. Behind the scenes, this sends a query that gets answered by Inu's worker thread. I'll have to document this at some point in the future. Last, we set up standard I/O transport to host our server. We add an idle callback to tick the Inu client and keep everything connected and in sync. I typoed the package name, fixing that now. This is what Claude's MCP config looks like. Because we're using Nim, R will automatically rebuild if anything has changed each time we reconnect. Next, we reconnect the MCP server. And we can see our tool is available. All right, let's make some basic tools for movement. The way I want this to work is to put a bot in the world that represents the MCP server so we can see it moving around as it's doing work. It will take screenshots from the perspective of the bot, it will do queries from the position of the bot, and if there are multiple MCP servers running, they'll all have their own bots in different colors. And we'll reconnect again and check out our tools. And we can see we've got the 3 tools. Let's add a screenshot tool. We also get to power this by existing queries. Normally it wouldn't be this easy. NimCP generates command descriptions from doc comments. So that's a finished V1 MCP server. Let's test it out. We'll ask Claude to follow us around and take some screenshots of us in front of some important landmarks. We'll wait here until Claude finds us. The green thing is just something weird that happened to wander into frame. But here's Claude. I have this running at 2x speed, by the way. And here are my glamour shots. Pretty stunning, if I do say so myself. I had Claude take a few more, but it was basically more of the same, so I jumped ahead to the last one. Cheese. And that's enough of that. Here's the final list of tools that are available in the MCP server. This has been expanded a little bit from what we did during the demo, but now the agents have a way to see which units are near a given area, to get the level directory. There's a concept of a block log, which is not something I'm going to get into and is not really used during this demo. It can read the console, it can set the position of different things, of itself, of players. It can wait for a script to finish running. So it can kick off a script and then know this will wait for it to finish, and then it can take a screenshot to see what it built. And different screenshots. So screenshot from the player's perspective, screenshot, the general screenshot that we've been demoing, and top down, and some movement and delete commands. When a level gets created, we add this Claude skills directory. So it has skills for adding a bot, for building a plan, a multi-agent plan. So in a little bit, we'll get Claude to put together a plan, a high-level plan that gets executed by 5 sub-agents. Instructions on how scripts work, how to place them in the world, different commands, things like that, how to build structures, buildings, furniture, moving, and just this is the state machine that I talked about at the beginning of the demo. We can do things like, just things like that. And this is the verification process, so it knows to wait for a script to finish running and then take a screenshot, and take screenshots from different angles and just different approaches for getting a clean build. And these are sign menus, which are not something we're going to look at right now. So here's the prompt that I gave Claude. I'm not going to go through the whole thing, but basically I asked it to create an alien city, 300 meters in radius, with a forest around it, things flying around in the sky, mostly black and white structures, lots of cool colors. Let's see how it does. So here's the world as Claude builds it. We'll explore it at the end. This whole thing took about half an hour, so it's been trimmed down quite a bit. You'll see all the important parts though. Claude decided to start with a centerpiece. It added this arc with a little spinning doodad on it and a spire behind it. The spire also has some spinning doodads. Some buildings in the background. And a lot more buildings in the background and more spinning doodads. I'm noticing a theme. Blinky things. A UFO. More flying things. No world would be complete without wobbly antenna. Look at them go. Here's a world Claude made. I'll give you a quick tour. We'll hit some highlights. Later on, I show a feature called environments that my son Vin came up with that are kind of like filter effects. And we also look at another world that Claude made before this one, but I messed up the video. It actually turned out a little bit better though, so I'm going to show some highlights. All right, enjoy.
Gather your friends and get ready to argue. There's blood on your hands and a gleaming sunset, dawning on an age, and I've seen a million words of nothing written on the page. I've seen the yoga come near and then you just fade. I've seen everything you've ever wanted slowly drift away. I've got an unwanted house, it's got an unwanted friend. I've got an unwanted means to an unwanted end. I've never been so excited, I finally can't pretend that I'm really not out of fun. It isn't a problem that I